Mathematics 2 Chapter Integration. Tutorial question 57I. Integrate ln ax with respect to x. Now, before you integrate, let's try to expand the ln ax by using the rule of logarithm. Yes, you can expand it as ln a plus ln x. Hence, you can directly integrate. Ln a is just a constant. Integrate a constant will be x ln a. Meanwhile, integrate ln x. You know the formula. It will be x ln x minus x plus c. Now, if you notice, these two terms has a x in front. So I'm going to factorize x, left with the factorization of ln a plus ln x minus x plus c. Now I'm going to simplify further, which can be written as ln ax minus x plus c. Remember, if you have addition, if you want to combine the same base of logarithm, it will become multiplication. This is the answer for the I. Now let's try to do J together. We have integrations from 1 to 2 x cubed e x to the power of 2 dx. Now we're going to use IBP to integrate this function. Now, to use IBP, you always need to choose your u first. Priority goes to u by following the LATE order. So if you notice, we have algebraic, which is your x cubed, and we have exponential, which is ex squared. So by using the rule of order late, you know x cubed will be your u, dv will be your e squared. The problem raised when you want to integrate your selected dv. If you notice, ex squared cannot be integrated directly. Hence, I will make a few changes in terms of my selection. What will I do is, basically, I'm going to separate my x cubed to become x squared times x squared. If you notice, I do not make any changes. I just separate the x cubed to become two terms. X squared times x still will produce x cubed. Why I do so? Now I can choose my u and dv correctly, where my u will be x squared, my dv will be x squared. Correct. You can directly integrate x squared by using the recognition method. If you still remember, if you have f prime x fx, you will got the result of fx. Now let's do this integration first. You notice you have ex squared. Now x squared will be your fx. What will be the f prime? Yes, it will be 2x. Now if you integrate these, you know the answer will be fx, which is ex squared itself. Let's directly substitute the fx. Now this recognition method is correct. However, look back into your original function. Do you have 2 here? No, then what you need to do? Yes, you have to normalize or standardize your coefficient. If you don't have 2 and you add 2, then you need to make sure you multiply by 1 over 2 again, because 1 over 2 times 2 will become 1, which is actually the original function. However, if you make changes in left hand side, you also need to make changes in right hand side. Now, this is the correct integration. You will already obtain your v value. How about your u? Yes, your u, you just simply need to differentiate your u with respect to x, obtaining the result of 2x. rearrange it, you know your du is equivalent to 2x dx. Now your next job is to use the IBP formula, which is uv minus integration v du. Now substitute all the necessary information. Your u is x squared, your v is 1 over 2 e x squared minus v again, which is 1 over 2 e x squared, times with du, which is 2x dx. Now if you notice, this can be cancelled out. Now let's try to simplify the equation. You have x squared e x to the power of 2 divided by 2 minus, after you simplify, you only left with x e x squared dx. Now you need to do another integration, but please remember, you see or not the pattern, you want to integrate x e x squared dx. Here in the previous dv, you already integrate x e x squared. Hence, you already obtained the solution for that integration. You can just replace the integration of x e x squared to become 1 over 2 ex squared. Let we erase and replace our solution accordingly, which is 1 over 2 ex squared. Since this is the final integral, you will replace the limit from 1 to 2. I believe this one you can solve by yourself, giving you the solution of 2e4 minus e4 divided by 2, giving you a result of 3e4 over 2, or you can also write it as 81.897. That's all for question 57J.